7.2 and 7.3, the remainder theorem, the factor theorem, and the rational zeros theorem. First, we're going to look at the remainder theorem. The remainder theorem states that when a polynomial, f of x, is divided by a binomial in the form of x minus m, the remainder is f of m. In other words, if you plug in a number for x, the remainder is what you would get for y. So how do we recognize that we're going to be using the remainder theorem? The directions will say evaluate when x is a certain number. So if they're asking us to evaluate, that means we're going to use synthetic division and divide, and the remainder is going to be our answer. So we're dividing by -2 because x is -2. We have 1x to the third plus 4x squared minus 5x plus 3. Make sure there's no missing terms. Write your coefficients. Bring down the first number and then multiply by the outside. -2 times 1 is -2, and then add your column. 4 minus 2 is 2. -2 times 2 is -4. -5 minus 4 is -9. -2 times -9 is 18. 18 plus 3 is 21. So the remainder is what we're looking for. That's our answer. And so we're going to write our answer as f of -2, because that's what we were looking for. We were looking for x is -2, equals the remainder 21. All right, so the next example, evaluate f of x when x is equal to 1. So evaluate when x is 1. That means we're using synthetic division. We're dividing by 1. -2x squared minus 8x plus 10. Bring down the -2, multiply by the outside. -8 plus -2 is -10 times 1. Okay, the remainder is 0. So we're going to write f of 1 equals 0. Okay, so that's what the remainder theorem is. You can always check your answers by plugging them in. So f of -2, we could plug in a -2 into x into f of x. So -2 cubed is -8 plus, remember, order of operations, square the -2 first, then multiply it by 4. -5 times -2 is 10. -8 plus 6 is 8. Plus 10 is 18, 19, 20, 21. Okay, so here if we wanted to check it, same thing. We could plug in a 1 for x. One squared is 1. -2 times 1 is -2 minus 8 is -10 plus 10 is 0. All right, the second thing we're going to look at is the factor theorem. The factor theorem states that when a polynomial is divided by x minus m and the remainder is 0, then m is a solution and x minus m is a factor of that polynomial. So divide the polynomial by x minus 3. So we're going to use synthetic division to divide it. If x minus 3 equals 0, then x equals 3. 2x cubed negative 11x squared, 3x, 36. Make sure you're always checking for missing terms. Bring down the 2. 3 times 2 is 6. Add the column negative 5. 3 times negative 5 is negative 15. Add your column. 3 times negative 12 is negative 36. So f of 3 equals 0. So 3 is a solution. And x minus 3, what you divided by, is a factor. All right, our next example says that if one solution is x equals negative 1, find the other two solutions. So if one solution is negative 1, that means that if I divide by negative 1, I should get a remainder of 0 because they're telling us it's a solution. So bring down the 1, multiply negative 1 times 1 is negative 1, plus 4 is 3. 3 times negative 1 plus negative 15. Negative 1 times negative 18 is positive 18 is 0. So we're going to find the other solutions by factoring. So we're going to have f, we're going to have x minus negative 1 times remainder constant x squared, 1x squared plus 3x minus 18. We're finding solutions, so we're setting f of x equal to 0. So remember this factor came from here, and then this came from here. Then we can factor further. So x plus 1, factor the quadratic, x times x, 3 times 6 is 18, 6 minus 3 is 3. Set them each equal to 0, so x equals negative 1, x equals 3, and x equals negative 6. All right, well, how could I check these if I wanted to check them? I could divide 3 and make sure I get a remainder of 0. And then I could divide all over again, or I could just continue from here and divide the other one, negative 6. So negative 6 is correct, 3 is correct, and then if I look at this, x plus 1 would give me the negative 1. So I've checked all three solutions. All right, the next example, write 3x cubed plus 8x squared plus 3x minus 2 in factored form. So that means that we want to write in factored form, we want the sets of parentheses, given that x plus 2 is a factor. So if x plus 2 is a factor, that means if I divide by negative 2, I should get a remainder of 0. So that's how we're going to start. Okay, so we divide by negative 2, we get a remainder of 0, and then we're going to write in factored form. So we're setting it to f of x, because we want f of x equals, so x minus negative 2, x plus 2, times remainder constant x, x squared, 3x squared plus 2x minus 1. And then we want to factor that quadratic further. Now, sometimes you can't factor it further, but you always have to at least check. So 3x times x is 3x squared. 1 times 1 is 1. 3x minus 1x is 2x. So this is our factored form. All right, and then our third theorem is the rational zeros theorem. Use the constant. The rational zeros theorem uses the constant and leading coefficient to determine all the possible rational zeros. Rational zeros are numbers that can be written as fractions. Solutions, zeros, roots, and x-intercepts are all the same thing, and it is equal to whatever the degree of the polynomial is, the highest exponent. So to list the possible rational zeros, this is going to be our p over q, and p is factors of the constant. So remember, remainder constant x squared. The constant is the number at the end without a variable. And the leading coefficient is the number in front with the highest exponent, the coefficient of the term with the highest exponent. So first, let's look at factors of p. So factors of 10. What are numbers that divide 10 evenly? Positive or negative 1, positive or negative 2, 5, and 10. You can write them like that, or you can write them as pairs, plus or minus 1 and plus or minus 10, plus or minus 2 and plus or minus 5. So 1 times 10 is 10, and 2 times 5. And then q, factors of 2. What are numbers that divide 2? Just 1 and 2. So all the possible rational zeros are going to be our p over q. So if I start with a certain q value, let's start with 1, then I'm going to do all of those p's over 1. So if I start here, 1 over 1 is 1. And then 2 over 1 is 2. 5 over 1 is 5. And 10 over 1 is 10. Now I've finished with that q, so now I'm going to move on to the next q. So now p over 2. So 1 over 2 is 1/2. 2 over 2 is 1 whole. I already have it, so if you already have one, don't write it again. 5 over 2 is 5/2, and 10 over 2 is 5, and I already have that one. So these are all my possible rational zeros. These are the numbers that could possibly give me a remainder of 0 if I use synthetic division. So why do I need to know this? I need to know this because in the examples that we've given so far, it says given x plus 2 is a factor. One solution is -1. But if they don't give you a starting point, your P over Q list is your starting point. That's where you're going to decide what numbers to use with your synthetic division, and you're looking for a remainder of 0. All right, so list all the possible rational zeros for f of x equals 6x squared plus 7x minus 18. So P is the factors of the constant term. Q is the factors of the leading coefficient. So factors of 18. 1 times 18, 2 times 9, 3 times 6. Okay, notice that they all have a plus or minus in front of them. You have to write a plus or minus in front of each number. And then Q is 6, so factors of 6. 1 times 6, 2 times 3. So then to find all the possible rational zeros is going to be all the combinations of p over q. So if I start with 1 for q, I'm going to do all my p's over 1. So 1 over 1, 2 over 1, 3 over 1, 6 over 1, 9 over 1, 18 over 1. Then we're going to move to all my p's over 2. So 1 over 2, 2 over 2 is 1. I already have that one. 3 over 2, 6 over 2 is 3. I already have that one. 9 over 2, 18 over 2 is 9. I already have that one. All right, next, move on to the next q, 3. 1 over 3, 2 over 3, 3 over 3 is 1. I already have that. 6 over 3 is 2. 9 over 3 is 3. I have that. 18 over 3 is 6. I have that. And then finally, all of my p's over 6. 1 over 6. 2 over 6 is 1/3. I have that one. 3 over 6 is 1/2. I've got that. 6 over 6 is 1. I've got that. 9 over 6 reduces to 3/2. I have that. 18 over 6 is 3, and I have that. So 1 over 6 is my last p over q. All right, so to find all solutions, we're going to list the possible rational zeros. That's your p over q's. Guess and check to find one or more solution. That's synthetic division. Look for remainder to be 0. And then you can factor and solve by square root or by the quadratic formula to find the final solutions. So remember, the number of solutions is going to depend on the degree. So for this one, it's a quadratic, it's x squared, I should have up to 2 solutions. If I have an x cubed, I should have 3 solutions. An x to the 4th, I can have up to 4 solutions. So you want to look at this to make sure you're finding all of your solutions. All right, so for this first example, we'll have 3 solutions. So we're going to start with step 1. We're going to find our p over q's. So p is 10, q is 1, so it's going to be everything over 1. So when it's everything over 1, we can just go straight to our p over q because we don't have multiple q's to have to make the fractions. So factors of 10 are 1 times 10 and 2 times 5. And all of those would be over 1. 1 over 1 is 1, 2 over 1, 5 over 1, 10 over 1. All right, so then our second step is to take these numbers and use synthetic division to see if we get a remainder of 0. So if I divide by positive 1, so these numbers are coming from here, my polynomial, use synthetic division. Okay, and I got this one on the first try. That's not always going to happen. If it didn't work, then I would try -1 next. If that didn't work, I would try 2 and -2, 5, -5. You don't have to go in order. You can choose anything from your P over Q list. All right, so then we're going to use that factor theorem. We're going to write this in factored form. F of x equals x minus 1 times remainder constant x squared minus 3x minus 10. Factor further. 2 times 5 is 10, minus 5 plus 2. And then we're finding the solutions. The solutions are when we set it equal to 0. So x equals 1, x equals -2, and x equals 5. And I said that I should have 3 solutions, and I found 3 solutions. All right, so let's try this one more time. 2x cubed plus 5x squared minus 11x minus 14. So again, I should have 3 solutions. We're going to start with our P over Q. This was step 3, was factoring and solving. All right, so step 1 is to find our factors of P. So 14, 1 times 14, 2 times 7. Q is 2, so 1 times 2. And then P over Q, everything over 1. And then after that, we'll do all of our P's over 2. So 1 over 1, 2 over 1, 7 over 1, 14 over 1. Now move on to your next Q, 2. So all of your P's over 2. 1 over 2, 2 over 2 is 1, 7 over 2, 14 over 2 is 7. All right, so we can guess and check anything from this list. So if I, again, start at 1, all right, so 1 is not a solution. So we can try -1. And -1 is a solution. So then we can write that in factored form. So step 3, f of x equals x minus -1. So remember, don't forget the one that you divided by. That gives you a solution and a factor. Times 2x squared plus 3x minus 14. Factor further. 2x times x is 2x squared. 2 times 7. So 4x and 7x. So 7x minus 4x. And then we want the solution. So we let f of x equal 0. Let y equal 0 to find x. So x is -1. X is -7/2, and x is 2. All right, so the next example, x cubed minus 2x squared plus 9x minus 18. We're finding all the solutions. We're setting it equal to 0 to find all the solutions. So first, p is going to be my factors of 18. Q is 1. So first, find our p over q. Since q is 1, it's going to be all the p's over 1. So we can just go ahead and go straight to p over q. So 1 times 18, 2 times 9, 3 times 6. Then use those numbers to find a remainder of 0. So I always start with like 1 and -1, then go 2 and -2, but you don't have to. You could always just start from anywhere on the list. Like you might want to start with 3. Okay, that's not going to work either. All right, so 2 worked. So we're going to write f of x equals x minus 2 times remainder constant x squared. All right, so we're solving. So we want it equal to 0. We want f of x equal to 0. And then x squared plus 9 is not a difference of squares because it's not a difference, it's a sum, and it cannot be factored. So it stays. And then if x minus 2 equals 0, x equals 2. If x squared plus 9 equals 0, x squared equals -9. Square root both sides, x equals plus or minus 3i. So my 3 solutions are 2 and positive 3i and negative 3i. All right, so the next one is x to the 4th, which means I'm going to have 4 solutions. So first, start with our p over q. So again, since q is 1, it would be all the p's over 1. So we can just go straight to p over q. So 24 is 1 times 24, 2 times 12, 3 times 8, and 4 times 6. Okay, so there's a lot of numbers to choose from to try our synthetic division. Remember, we're looking for a remainder of 0. All right, got this one on the first try. Now remember, if I write it out, remainder constant x squared, x cubed. So this is an x cubed. It's not a quadratic yet, so I would have to factor it some more. So let's just continue our synthetic division. We can try 1 again. That does not give us a remainder of 0. Sometimes the one that worked might work again. Sometimes it won't, so you can just try it and see if it works again. If not, try a different number. So we're still using our same P over Q list. Okay, that didn't work either. All right, -2 did work. All right, so when we write our next step, remember we're going to have, we divided by 2 things. So we're going to have x minus 1 times x minus -2, or x plus 2, times remainder constant x squared plus 1x minus 12. And then factor that again. So once you get an x squared, that's when you can just factor. If you're down to an x cubed, you need to use synthetic division again and find another 0. Okay, and then we can set this equal to 0, make f of x equals 0, so we can find the solution. So x equals 1, x equals -2, x equals 3, and x equals -4. And it was x to the 4th, and we have our 4 solutions. All right, the next one is x cubed plus x squared minus 6x plus 4. So we'll start with p over q. Again, q is 1. Makes our p over q a little bit easier. 1, 2, and 4. So 1 times 4 and 2 times 2. So we have fewer things to guess and check from. All right, so our remainder is 0, so we can factor that. So f of x equals x minus 1 times remainder constant x squared plus 2x minus 4. So 2 times 2, 1 times 4. All right, so what do we do when we can't factor that quadratic? Well, we're still setting it equal to 0. This one would be equal 1. But for the other one, if I can't factor that, I have to solve it a different way. Well, we learned that you can solve by completing the square, or you can solve by quadratic formula. So quadratic formula is probably the most common method that people will use. So x equals -b plus or minus the square root of b squared minus 4ac over 2a. Negative times negative is positive, so it'll be a plus. 4 times 4 is 16. 2 times 1 is 2. 20. The 20, I can break it down to 4 times 5. So x equals 1 and x equals negative 1 plus or minus the square root of 5. And when we have a plus or minus, that gives me two solutions, because one solution is negative 1 plus the square root of 5. Negative 1 minus the square root of 5 is a second solution, and then x equals 1 is my third solution. All right, and for this last set of examples, we're going to work backwards. So this time we're given the solutions, and then we're going to write the polynomial. So we're going to start with the solutions, and then put it in factored form, and then change it to standard form. So write the polynomial means I'm going to have f of x equals, and then if the solution was negative 2, the factor was x plus 2, because if I set x plus 2 equal to 0, minus 2 minus 2, x equals negative 2. And then what factor would give us 7 as a solution? X minus 7. So then to write it as a polynomial, we're going to multiply that out. So x times x is x squared, x times negative 7, 2 times x, 2 times negative 7, combine like terms, and then make sure your polynomial always has f of x equals or y equals in front. So f of x equals x squared minus 5x minus 14. So for the next one, if you have a 0, this is going to be like x minus 0. What's x minus 0? It's just x. If one solution was 4, the factor that gave us that was x minus 4. Because if you set x minus 4 equal to 0, then x equals positive 4. And then 1 would be x minus 1. Then multiply it out. I'm going to multiply these two first. So x times x is x squared minus 1x minus 4x. Negative 4 times negative 1 is plus 4. Combine like terms. And then distribute the x. X cubed minus 5x squared plus 4x. All right, and then the last one. If x equals 4i, then x minus 4i equals 0 gave us 4i. X plus 4i gave us negative 4i. And x minus 5 gives us a solution of 5. So then multiply these two together. X times x is x squared plus 4xi minus 4xi minus 16i squared. Do you remember what I squared is equal to? It's equal to negative 1. So it's negative 16 times negative 1 plus 16. So x squared, that equals 0 plus 16 times x minus 5 X squared times x is x cubed minus 5x squared plus 16x minus 80.